A charged particle A of charge 2 coulomb, here is a charged particle A having charge 2 coulomb, has velocity v 100 meter per second. When it passes through point A and has velocity in the direction shown here at an angle 30 degree with this particular line, let's see what is this. The strength of magnetic field at point B due to this moving charge is R is given to be 2 meter. So because of this moving charge, we have to calculate magnetic field at this point. How this charge is going to produce the magnetic field? Because the moving charge is nothing but a current. Moving charge is what? Equivalent to current. So there must be some magnetic field because of this moving charge. So let us calculate that. Calculate this particular magnetic field due to this charge when the charge is at this location and moving in this direction. We have to do a little bit tweaking in Biot-Savart law. So what is the Biot-Savart law? In case of Biot-Savart law, if there is a current segment, say very small segment of length dl, so dl vector having direction in the direction of current, okay, and here it is a point where we have to calculate the field. Say this is a point. So field at this point, because of this current element, means here it is a current conductor, and suppose we have considered only dl length of this conductor, then due to this dl length only at this point, suppose this is r vector, then field at this point according to this Biot-Savart law is dV is equal to mu naught upon 4 pi I dl vector cross product with position vector r divided by cube of its magnitude. So that is how the magnetic field due to a current segment can be written. So here also we can assume it like a current segment. If we suppose allow time interval of dt second, then it will cover a distance of how much? V into dt. So we can use V into dt in place of dl. So we can treat it as a current element. So how do we modify the things? Let's see here. So it is mu naught divided by 4 pi into I, and in case of dl we can write V vector into dt cross product with r vector divided by r cube. Here it is r vector for this point. Okay, so now, and what is this? dl, not dl, it is dt. V into dt. In place of dl we are writing V into dt. So let us put dt along with the current. So now you can get the idea what I am going to do here. I into dt is the charge, that is the charge of the particle which has crossed this particular point in time interval dt. Okay, so current into time interval is the amount of charge, that is q. So in this case the magnetic field due to this segment only will be written as mu naught upon 4 pi into q v vector cross product with the r vector divided by r cube. So we have tweaked this Biot-Savart law to find the magnetic field due to a charge. So in place of dV we can simply write V also, because we are going to do this calculation for the particle, a charged particle, and we are going to perform the calculation just for this instant. Okay, and we don't have to integrate this. So that is the total magnetic field. So now this magnetic field B can be written as mu naught divided by 4 pi into q into v into sine theta divided by r square. As you can see, I have cancelled one r from the numerator. So now we can substitute the values here to calculate the magnetic field B. So in place of mu naught upon 4 pi, what is it? 10 raised to the power minus 7 multiplied with here the charge value q, it is 2 coulomb, into velocity 100 meter per second, into sine theta, it is half, theta is 30, divided by r square, it is 4. So how much are you going to get? Is this 25 into 10 raised to the power minus 7. Okay, so it becomes 2.5 into 10 raised to the power minus 6 Tesla. That means 2.5 micro Tesla. So option A will be the correct option for this question.